This is Mastering Mathematics with your teacher, Karen Weston.
Good evening. Welcome to this, another in the series of Mastering Mathematics. I'm your teacher, Karen Weston. And guess what? Elizabeth had so much fun the last time that she's here again today to make certain that we can be a tag team, and we will be taking you through matrices once again. Remember, we spoke about the addition of the matrices, subtraction for the matrices. Elizabeth, what did you bring to help us with our addition and subtraction?
Sure.
And you brought in this rule that we can say we know how to add and to subtract our negative numbers. So we had
directed numbers.
Yes. So the whole
rule.
Right. We had the whole principle of a slide rule. Did you make one at home for yourself? Are you practicing? And you found it easy. All right. So directed numbers must not be anything of a burden to us once again. Keep on practicing and it will come. Now, we told you the last time that we had two types of multiplication for matrices. We showed you the scalar, which was the same thing as your distributive law. And we also showed you a specific multiplication that was unique just to matrices. And then we were using a possible case where we can have A and it's equal to 5, 4, 2, 6. And it is multiplied by the matrix B, which is equal to 3, 4, 7, 8. All right. And it's so times 3, 4, 7, 8. And what do we have? We have a perfect scenario, a perfect case where the first row matrix would have given us rows, the second the columns. Okay. We also spoke about the order of a matrix, and we said the order was same amount of rows as columns. Okay, that must be present for the multiplication to take place. Elizabeth, what happens when this does not happen? When we don't have the same number of rows and columns, we can be in
our columns must match our rows.
Okay, 4, 5. Okay, let's put back this as 3, 4. Okay, now what did we say the last time? If we look at the matrices that we have here, P is equal to 1, 2, 3, 4. So we have a 2 by 2 matrix. Yeah. When we look at Q, we have a matrix which has 3, 6, 4, 7, 5, 8. So this is a 3 by 2 matrix. Can we do the multiplication for this? Where we have one matrix. So if I wanted to multiply P times Q, what would happen then? So we have from our first matrix, we would have 1, 2, 3, 4, and it is times 3, 6, 4, 7, 5, 8. All right, we have 2 rows, 2 columns, but what is the problem here, Elizabeth?
Well, we've learned that we multiply row by column.
Yes.
Right? So if you take the first row, we multiply it by the first column. And if we notice, the first row has 2 numbers, and the first column has 3 numbers. So if can we really do that? Because one number multiplies with one number, and if there will be 2 numbers with 2 numbers, and they will be left with one number dangling.
One number dangling. So we can't say the things in the same positions are multiplied together.
So notice
this cannot be done. Okay?
Happen because our first one was a 2 by 2.
This with first number,
matrix, and the second
this
was
by that
3 by 2.
Right.
And we saw that the
orders
column will not equal to the rows. The
All
column
right.
in the first matrix will not equal to the rows.
Okay,
So,
the elements are missing.
therefore, right? That can't work.
That can't work because we're just going to be saying 1 times 3. So it will be getting something like 1 times 3, and it's plus 2 times 4, plus what times 5? Nothing.
Yes.
All right, so it's impossible. So we have to notice that the order must be the same in both matrices that we want to multiply. These are some of the things that you can get on your multiple choice paper, which is possible.
The order of the column must be the same as the
Matrix with the rows.
You must have
Okay.
the same number of columns and the number of rows in the order.
The elements must have the same number of elements.
The column in the
First matrix,
first matrix must be the same as the rows in the
second matrix, and that is not so.
That is not so.
All right, so this cannot be done. So we see that right away. These are some of the things CXC can ask you in that multiple choice paper. Which one of these multiplication is impossible? All right, and we know why. Because even if you're doing your multiplication here, watch here. 1 times 3, 2 times 4, what times 5? There's nothing to go with it. All right, so the order must be the same. Today, we want to move on from the multiplications because you know how to add, you know how to get to your tool for that our slide rule that we have made. Notice what we're trying to make you. We're trying to make you not only mathematicians, but we're also trying to make you innovators and not consumers. We're going to continue because remember, the topic of matrices came in to show you that it can be used in solving a simultaneous equation. And my 5th form students, this is one of your section 2 questions. So notice even before this Christmas vacation, we are making certain, because afterwards I'm going to count up the marks, you know, and show you how much marks you should have been getting from that exam paper already. So don't tell me you're going to fail that mathematics. It is too simple. Sit, do the work, keep on practicing. Elizabeth, won't you agree with that?
Yes.
Okay.
Keep on
Practicing. Keep on practicing. So we are marching on towards this place where we can bring you to a position where you can use matrices to solve a simultaneous equation. But before we get there, there are 3 new words that we need to introduce you to, and what and how we define them. The first one we're looking at, determinant. Okay, so this is a word, and that is why we tell them all the time, introduce the children to the terms. Okay, determinant.
Find the inverse.
Oh, right. So we are going into this term, and it is being used. Yes, we have 2 words we are using here now, determinant and adjoint. And then you see we have the inverse because they are related. From the determinant and the adjoint, we will be able to find the inverse of the matrix, which is what we are heading to right now. But before we do that, we're going to take some time and show you the definition and how it is the formula for finding the determinant. So suppose we're given a generalized form of an equation A, which is equal to, with elements A, B, C, D. A, B, C, D. We say the determinant of A, and we can write it that A, because I'm showing you all the short form, because mathematicians don't like to write out long words, you know. So they're going to write that A, or you're going to see 2 strokes and the A in it, which we call it, note this word, it is called modulus A. Okay, and it is still asking us for determinant. So we have given you the 3 forms in which they can say this: determinant of A, or you can just see that A, or you can see modulus A. Normally when we put it as modulus A, is because they're telling us we want just the positive value of whatever we are getting. All right? Elizabeth, would you like to give them the formula for the determinant of the matrix?
Yes.
What do we say?
We're using our column there. We're going,
yes.
If I can see it well.
Here.
Right? We have it here.
Yes.
We're going across this way.
Right, like an X.
Across that way. Going across that way.
Wait, so let's put it in. I told you already.
That way.
Okay,
right?
so that going across this way.
That, right? Yes, going across that way first.
So when we go across that way, what we're writing is AD.
Right, so write it down.
Yes.
AD. Good.
Yes, we did that.
AD.
I'm using another one.
Good.
Yeah.
And then
minus.
we put a minus sign.
Yes.
And then we go across the other way.
Right. So we
get
bring
AB.
Right. So BC.
B. And the operation there is that we are multiplying.
BC.
Multiplication.
Right.
Yeah.
Good. So notice again, we remember when you see two letters like that, we have left out a multiplication sign, so it means A times D, and it's minus B times C. Okay, so when we're writing it, we just write AD minus BC. Okay, so if you're going to give me,
okay with that, right?
Right? No. So again, we are saying to find the determinant of given any matrix, generalized form, it is just as if we're forming an X, so it is AD minus BC. Okay, just now I'm going to give you some numbers. So suppose I had this matrix now, and our A this time was equal to, I don't like to write with the greens because I know what you're saying. You can't see it very well, but listen to my voice too, because you're writing with me on your paper. All right? So if we have the matrix A and it's equal to 2 and it's 5 and it's 4 and it is 6, and we want to form the determinant, it doesn't take too much to just write, to give you a little chance to remember that this is my A, that's my B, that's my C, and that's my D. And draw the arrow just like you did to say that this is the X's, okay? So if I had 2, 5, 4, 6, all we're doing now, we're saying then, it is now equal to 2 times 6, and it is minus 5 times 4. And it doesn't even matter if you wrote 6 times 2 and then 4 times 5, because we say multiplication is commutative, all right? But so we want you to say it is AD minus BC, and then the multiplication. My primary school children, 2 times 6 would have given you, see, I tell you about those multiplication tables, boy, important. And it's minus 5 times 4 would have been 20. Now what we have here, the sign goes with the second number, so we have a positive 12 with a negative 20.
Oh. Positive 12.
With a negative 20.
Good. So if you have your slide rule.
Exactly, tell me.
0 on the 12. And you're going down
20.
If you look above negative 20, what are you going to see?
Right.
Negative 8.
And it's going to be negative 8. Daddies and uncles and mummies, make certain you tell them about that slide rule. See, it comes in again. Okay? And for my big people, you're saying, which number is bigger? The negative one, right? By how many? Okay? And you're getting it. But you see your little sister is coming better than you. All right. So we introduce you to the determinant. We know we can see it in 3 forms. Determinant of A, or it can be just saying det A, or it's modulus A. And simple, if you have a generalized form of an equation, it's just like you're doing the x's. So it is AD minus or BC. Showed you an example here, and you can see how we got our answer, and it is nothing more difficult than that. We give you a little chance to absorb this, so we ask you to take a quick break, don't go too far, because we expect you to know this and be nodding. So you just need a little time just to stretch, and we'll be right back.
If you know the answer to a question is incorrect, and you cannot find the mistake, start over on a clean piece of paper. Oftentimes when you try to correct a problem, you continually overlook the mistake. Starting over on a clean piece of paper will let you focus on the question, not on trying to find the error. Always read math problems completely before beginning any calculations. If you glance too quick at a problem, you may misunderstand what really needs to be done to solve the problem.
So we're back from our break. We have done our determinant. We know exactly how to do that. What did you say? You want us to try one more to make certain we know it? Okay, we're going to give them one more example with the determinant before we take them on to the adjoint. Now, suppose we had P and it's equal to, this time we're going to give them -2, -4, 5, and 6. And you're asked to find det P. Okay, yes. Det P, what are we going to say? Again, we'd state our formula first so that we know that it is AD. It is AD minus BC. And up here we'd have scribbled our little A, so we know this is the B, that's the C, and that's the D. All right? So notice, I know I wrote it very small, but I'm saying the A would be -2, the B would be our -4, the C would be our 5, and yes, and the 6 would be our D. When we write AD, we say it means A multiplied by D. So then it will now be equal to -2 times 6, and it is minus, this minus sign has nothing to do with the value of B, which is a -4. Put it in a bracket if you feel that you're not going to remember. Okay, so you don't drop the minus that is in the formula, because this is called -4. The name of this number is -4, so you don't throw away the sign. Okay, and then it is times 5. So we needed to show you one with the negatives, because people think that the negative is out there, so if you get -4, you just throw away the negative. And the name of that number is -4. All right? Then we're doing our multiplication. Multiplication takes a different rule to when we are adding the directed numbers. What do we always have to say when we're multiplying, Elizabeth? A negative times a positive will give us? A negative. So it's negative. Take care of the rules first, okay? Of the signs first. And then you're doing your ordinary multiplication. 2 times 6. What did you say, little one? 12. That is correct. -12. Now, take your time and address the signs first. There's a negative sign outside here. There's a negative number here. So the sign here is negative, and then there's a positive number over here. So we're going to be saying, walk it through. A negative times a negative would give us a positive. Yes. And then the positive times the positive is just positive. So, and then we can write our plus, and then we're saying 4 times 5 would give us, did you hear them giving you the answer, Elizabeth?
20.
They said that?
Yes.
All right. So they're learning their tables? Yes. Okay, they're learning the tables. Plus 20. Okay? So, right. And if you're practicing, after a while, you'll see if you have an even number of negative signs, your answer will always be, what would it always be, Elizabeth?
But you're adding 2 negatives?
No, not if we're adding. If we're multiplying and we have an even number of negative signs. Let's go again. Even number of negative signs.
End up with a
positive sign, because we are multiplying. Okay? No, yes, right. But that is when you practice. So don't try this. Do what we're telling you right now. Baby steps.
Step by step.
Thank you. Never get wrong. A negative times a negative, positive. And then a positive times a positive. All right? Notice we're not getting in any trouble. You have sufficient time in the examination room to be as accurate and to be as diligent and to take all the time you need to do this little part. That time is factored in. All right? So make certain your brains are looking and you're doing just that. So that's the multiplication. And this time we have negative 12 plus 20. What are we going to do, Elizabeth?
Oh.
Negative 12 plus 20.
Oh, that's a good one.
Uh-huh.
Right. So we put our 0 on the negative 12.
Yes.
And we go over to 20.
Uh-huh.
And above 20 we see 8.
Right, because positive 20 means we're going in a right direction.
Yes.
Okay? So then we look right over that and we would see.
Yes.
My little friend, did you use your slide rule? Did you see that? All right. So it is working. Practice it and you will see. Okay? And my fifth formers, you're saying, which number is bigger? And it's the positive number 20. Yes. And by how many? All right? And that's why our answer here is a positive 8.
The rule, you can come up with your own rule.
Exactly. So don't say the textbook. It's not the textbook. Teachers, we are supposed to make the concepts, the things that we're teaching our students, a part of us. Let us make it so and that we enjoy how we are communicating it to them. If it's a topic we don't understand, no harm in calling somebody to ask, how would you put out this to your students? How would we get it? I've tried this method, but it's not working. That is what we're talking about, collaboration. All right? And it can be done. It's not, I don't want anybody to know, I don't know. The more you ask, the more you will grow. Okay? That is what it takes. And we have to thank the government, we have to thank the Ministry of Education for the foresight. Remember, each teacher in Antigua now has a laptop. And things are making available too, that you can get the internet. So go and check on it and see, because there's so many packages also on that. So teachers, make use of the technology. All right, and I know that the IT persons are working very hard and they have already showed us how to integrate the technology into our mathematics class. Yeah. Didn't we have a good workshop, Elizabeth, with that? And how did the teachers take it?
Yes, very well.
All right, teachers are very, very good with that. So what do you expect to happen when those children get those those iPods?
I think they'll do well, especially if they're used effectively.
All right.
I know one topic I would have liked an iPad to use with the children when I was teaching is three-dimensional trigonometry.
All right. So we can already see goodness and mercy will come out of having those things. We say we want to change our young people, give them positive things to talk about, so therefore do not put any negative aspect in their brains. All right? So again, we had time, we showed you how we're going to be doing things, getting the determinant, when we have negative numbers, how we are going to be treating them. So we show all the time that once you would have learned directed numbers on one occasion, you take it with you through any of the other concepts you have to use it in with mathematics. We hope you had a good evening, because we enjoyed presenting this lesson to you. So have a nice evening, enjoy what we just taught you, and tomorrow we're going to introduce you to another aspect, another topic in the matrix and our walk to finding how we use matrices in solving simultaneous equation. So Elizabeth, we're going to tell them good night until tomorrow.
Good night. Good night. Keep on practicing. Make sure you get that homework done.
Exactly. Because we know next year we will be smiling because you are going to be mathematics wizards. Have a good evening. See you tomorrow.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.